Hey everyone, happy Monday.
Hello, hello.
I'll be brave and go on camera.
Hello, guys.
Hello, hello.
Hey Christian. What is it? Oh, that's your mic. I was like, are you holding a hammer? What is that? Yeah, that's what I see. Do we have any turkeys in the call this week? Anyone? Okay, no turkeys. I guess they're getting hunted for Thanksgiving. Actually, no one, probably a lot of you don't do Thanksgiving. That's right. It's a weird US thing, I forgot.
Well, we do a Black Friday, except that every Friday is a Black Friday in November in Finland.
Oh, like crazy, like Christmas shopping. Yeah, I don't do
Yeah.
I don't do shopping. Would rather be programming.
And it's so unprecise, right? I get a Black Friday email every day, and it feels like, okay, is it Friday already? Is it a Black Friday? I don't know. Like it's.
And then they always have like Cyber Monday or something.
Yeah. It's confusing. But
They
I get to
try to
shop
create
every day.
They try to create a sense of urgency to make you feel like, oh, the deals are going to go away. I must buy things now. And then you have to come to kind of back down to reality and be like, I don't really need all these things. This is unnecessary.
That's a regular thought of mine. Yeah. Yeah.
I guess we can start, right? Or do you want to wait a few minutes more? Okay. So maybe let's start with a short recap from the EU meeting, what we discussed there. And first, we are considering if we should continue with these EU meetings because attendance there is poor. We don't have so many people in there, and most of people could join this meeting. So maybe it makes sense to just abandon European group However, we agreed that we will meet the next time, next Monday, and we will see about how many people will join. So, and we discussed about a few topics in there, like one additional use case for confidential container runtimes. And there was interesting question if we could support if image compatibility could support artifacts. So, for example, confidential containers, if I understood correctly, they download appropriate artifact runtime based on some hardware specifics, so they could use this image compatibility to make appropriate decisions. My answer for that was that maybe let's start and concentrate on the image spec, and we will see how far we will go and what we will agree, and then we can pull additional topics like that into discussion. Sorry, go ahead, Brandon.
I didn't mean to cut you off mid-comment there, but there is an open issue over on, I think it's image spec, that Bjorn's been working on to really define what an artifact versus an image is. And I need to jump in there and add my own comment, but there's kind of a push that says that an artifact or a container image, I'll start from the other direction. A container image is something that can be executed on a container runtime of some kind. And so if you've got an artifact, that tends to imply that it's not a container image. There are gray fuzzy areas in between the two. But when someone says they want to apply this to an artifact, I want to make sure that what we're talking about is something that's not designed to run on a container runtime, in which case, what compatibility do we have in that scenario?
I see. So I think the best if we pull this phone call into discussion, or he can just reply into email thread and I don't know, maybe provide some details of use cases and so on. And we can continue this discussion in there if it's really required or not. And then also
if it's at all related to some of the WASM stuff, they're kind of funny gray area where they're distributing content that can be run directly in a browser and also in a container runtime. And so it's one of these both. I would say in that scenario, just call it a container image for now, that it can also be run outside.
Okay, understood. The other topic was how we should validate, for example, kernel configuration and so on, for instance, against BIOS configuration. So for instance, you have loaded KVM modules, but you don't have enabled virtualization on the BIOS, so that is kind of false positive check. However, we have to, I think, set some boundaries in there. Like, for instance, if you see that KVM modules is loaded on the host, we kind of could expect that the virtualization is enabled in the BIOS, so maybe we don't have to go so deep and so on. And yeah, and basically we were discussing what kind of fields people expect to be there, and I think we got a common understanding that everything I described in the image compatibility document like fits their kernel configuration, kernel command line, kernel runtime configuration, and so on. Correct me if I'm wrong, Patrick, because you were there as well, but I think we got some kind of understanding that this is what we require, at least initially. And I also had some thoughts about how we should. Yeah,
Sorry, I don't mean to. I'm not trying to cut you off on the comments there. Really, that's why I'm trying to like raise hands and throw things in comments instead of interrupting you.
Yeah. So yeah, and I had some thoughts on this email thread what we had. Like maybe we should divide this compatibility into two different groups. Like we have hard requirements and soft requirements, because I personally cannot imagine that based on kernel modules, we have multiple build of image container and put kernel modules into image selection and this kind of kernel configuration stuff into image selection. I thought to kind of distinguish what are the hard requirements like architecture, CPU stuff, and so on, that is really not easily, that cannot be configured, that is not configurable and cannot be easily replaced against the stuff that can be configured and can be easily replaced. I'm thinking here about kernel modules configuration, runtime configuration, and so on. So maybe it would make sense to extend a little bit the platform object with CPU stuff or platform details, but not include kernel stuff. I think I understand Bjorn's concern now about this kernel versioning stuff, that we will end up with multiple different, I don't know, downstream versions, and that would lead to having multiple images built and so on. So yeah, that's my thoughts right now about that. Is that clear, or maybe I should rephrase something? Sorry, I'm not native.
I guess I'll chime in there on that. Yes, I guess like that makes sense to me. So that this is maybe more yeah, I mean, this is maybe an aspect of what I've been trying to get at, which I think there's multiple use cases and multiple forms of compatibility information that people would find useful. And so I don't think there's necessarily, I mean, this is what I think I was trying to say last meeting, if I don't think necessarily there's one place where it makes sense to have everything. For example, I think that it doesn't necessarily partition itself neatly along like use cases and categories of functional check, but at the same time, I think there's a place for things like aiding in platform selection of an image, and that probably doesn't include things like kernel modules unless it does, because it could be things like, I don't know, NVIDIA out of tree drivers and then fall back to a neural network implementation that is purely CPU based. I guess there still could be a case for stuff like that, even if it's somewhat niche. And so I wouldn't rule it out entirely. And then likewise,
You're breaking up a little bit. I can't understand.
Yeah, the same here.
Are you still there?
Is that coming through?
Yeah, that sounds good.
Okay.
Sorry, please
So
continue.
yeah, so I was saying I think this is a bit similar to what I was talking about last week, where I think there's multiple places that it makes sense to have this information for, you know, quote unquote soft or hard requirements. And I don't think even the categories of information that you might want to have available or make decisions on neatly partition along the lines of use cases or kind of blanket categories. I think there was a large element of mix and match that I can see people potentially wanting. So for example, one being like so-called hard requirements, where like I might want to do platform selection on an image. I might want to have multiple versions of a application and then select among them based on availability of NVIDIA out of tree drivers and therefore CUDA, or a particular CUDA version based on the version of the NVIDIA drivers. Or I might want to fall back to a machine learning implementation that is entirely CPU backed. Or similarly with the idea of like having compatibility as an artifact that you can use to annotate an image and then do a compatibility check on, you know, that I could still see you would want to be able to say match against CPU subarchitecture. Like maybe it turns out that the program optionally uses AVX 512, and it turns out that the AVX 512 implementation is flawed. And so, you know, now, oh, actually, you know, we don't want to use this. We don't want to take advantage of these CPU instructions, since, you know, the idea of like annotating an image after the fact to, you know, describe changes in compatibility, whether that's new validations or new discoveries of bugs or incompatibility happens. And the other thing I wanted to mention is to Brandon's earlier point, that image I've been working on the image specs, or that issue I've been working on the image spec side, has kind of blown up a little bit, and it's grown in scope from what I originally wanted, even if I think it probably is important to have somewhere a definitive explanation of what is an image and what is an artifact. What we've ended up with for now, the direction I'm trying to go to try to make it clear, is basically that the traditional image today is something that has a config like images of today, and everything else is an artifact. Where I'm trying to go with that is that I don't want to preclude runnable artifacts, if that makes sense. So basically, like, you could have something interpret an artifact as something that can run, which could be WebAssembly. But my idea is basically we kind of have this legacy image spec with this config, and today the WebAssembly folks want to take advantage of that config. And so that is a image because they want basically an existing runtime like Containerd to be able to interpret that image with minimal code changes. And then tomorrow, there could be other things like WebAssembly not having the totality of the, you know, quote unquote legacy OCI runtime configuration that includes things like C group setup, mounts, etc., that their applications may never need, in which case they would have an artifact that they would define according to their own WebAssembly community consensus on how runtime should interpret this form of WebAssembly artifact to execute it, instead of the kind of config conversion runtime spec that we have with today's OCI images. And where I'm going with that is part of that change. Let me link to this issue that I want to make, is to make it clear that artifacts don't have to have a platform, but they can optionally have a platform. And so, you know, as it applies to the work here, I would also imagine as artifacts don't have to have any of the compatibility metadata that we're talking about. If it ever becomes standardized in some form for traditional images, but do the same thing of it may optionally add more context on how to interpret, how to select the right artifact, and so it can be used.
Yeah, I want to
I've
piggyback
seen-
off of what you said a little bit. In a lot of the discussion in threads and email over the weekend or whatever, wherever that was. Right, and even in these meetings, there's been a lot of discussion about the specifics of, you know, kernel features and drivers. And I want to make sure that early on we establish the scope of what we're working on, because at times it's felt like we're trying to decide on those features, on those labels. But to me, it feels like, and I think I said this last week too, and I'll reiterate it, that we should be figuring out a compatibility spec. Maybe it's an artifact. What does that look like? That then a community that has a vested interest in a particular use case can then take it and take ownership of the details of that. So like we could do a lot of discussion in these calls about these particulars, but I think I would suggest that we actually focus on, okay, what does this compatibility spec look like? Let's come up with just you know, so for the artifact working group, I remember in the beginning we came up with just like a bunch of kind of proposals for it, and we talked through it, and then once we had those proposals, we applied them to the use case, like, okay, what would be missing here for the kernel driver use case or for the artifact that needs a platform kind of thing. Because I think it's very easy to get kind of stuck in this discussion about these nitty-gritty details. And so someone suggested earlier in this call that we should kind of be splitting the compatibility working group. And I think that makes sense, but I think we should come up with that structure first. And then with the specific use cases, split up and like see how the different ideas that we come up with work for those use cases. Does that make sense?
Can I continue? I think because I'm afraid of one thing by going this way. If we provide, because if I understood you correctly, you want to provide some schema and you expect communities with specific interest will fill with data. We just allow them like a way how they could do that.
Well, I think there should be rules and procedure for how they kind of implement what they're working on, if that makes sense. Because I think the worry that I have is that we are going to design something where the burden of like updating the thing for a field is going to fall on an OCI working group. And I think that would be hugely bad. I think if there's sort of in some kind of checks for a container with NVIDIA, well, NVIDIA, you know, developers should be in charge of that. They have the expertise, they have the incentive. It doesn't make sense to be something that is totally, you know, under the ownership of like a small group of people here.
I'm a little bit afraid of that we, for example, we will end up with multiple tools with shared like with some overlap between groups, and we will end up with a situation where, for example, me as an image author, let's say I want to build image compatibility, it doesn't have like special interest. I would like to let's say represent some kind of stuff like express some kernel modules dependency and so on. I end up with not having a standard tool provided by OCI, but I have to choose between some groups that deliver some tools with their specific language, maybe not language, but specific data and so on. I'm just afraid that we will go we will provide too much freedom that people will be lost in this. That's at least what I think.
So if I can real quick try to just make sure I'm understanding Vanessa correctly. I mean, what you're saying is basically what you're more interested in describing is data structures, conventions, and a decision tree, more than actually what is the data we decide on and how, you know, what is the
Yes,
data? How do you
exactly.
functionally test for it? Instead, create
And
a blank canvas that anybody can then say NVIDIA or a group concerned about a particular a particular facet or whatnot can then define like actually what is this thing, what does it mean, how do you test for it, but then how they encode that information and how you can interpret that information along with their guidance on how to test for it or discover it's available or not. That is the left to the user some assembly required, and we just create the framework for using that kind of information and that kind of standard consensus, agreement, standardization, and enabling communities to define their own compatibility, both in terms
Exactly.
of
And I think naturally what would happen is that there are a lot of parties that are invested that actually need this. They would work on, you know, their own compatibility, family compatibility spec, whatever you'd want to call it, that falls into this. And then I think naturally over time, you know, the one that you use for, I don't know, a particular kind of compatibility will sort of bubble to the top. And then as kind of Brandon pointed out in the chat, every new thing would not be a PR to an OCI repo. Like that is the future I'm worried about. And this kind of model would also support the smaller niche communities where there's like, I don't know, a couple national labs or something interested in a particular spec for a particular thing. And, you know, they're going to still be empowered to do what they need to do, even though they're not sort of as big as the other ones.
I kind of like the idea because maybe I misunderstood at the beginning. However, I'm still afraid that we need to provide some kind of tool and some kind of standard, right? For example, because if we give this to, let's say, specialized groups, they will end up with their own data and their own tools, I guess, to validate containers, because we will provide them framework how to do that, but the compatibility, the sanity checks will be on their side to verify if it's correct or not, right?
Well, maybe that could be in scope for like, okay, the compatibility group that we're in right now, we would be working on those data structures and rules, but then there'd be another working group that's working on really like the core, you know, standards for containers that are absolutely essential that we're worried would get sort of lost in the the Wild West out there. Like it feels, I don't know. I guess I don't share that worry, but I understand where you're coming from.
Yeah, I mean, that makes sense for me if we follow that way. And if we, for example, focus, like I could imagine that would work for this kind of maybe soft requirements. Like we could still work or have another working group that is working on this core requirements that provide some kind of image selection and put everything else to communities and some kind of groups that they can define what's compatible for them and what should work. Maybe that way. So as you already mentioned in the email, we could focus on the architecture stuff. I saw you basically send a link there.
Yeah, I was about to mention that. So are folks familiar with ArchSpec?
I'm a little bit.
Okay, so basically ArchSpec is what SPAC and a few other things use, and it's basically the core of it is a bunch of JSON files that describe different families of architectures and the relationship. So that means that, for example, when you're installing something with SPAC, you can get the detailed architecture of your system, and then you can walk up this tree and be like, okay, is this compatible with this more generic family, all the way up to the top to the most generic. So the idea with ArchSpec is that you would have some kind of compatibility family for it, and then maybe some kind of key value, and I'm not calling it an annotation because I don't know that it's an annotation, some kind of key value pair in this artifact that we create would be for the, archspec.architecture.cpu.microarchitecture, some key like that. And then you'd look it up, and in the most simplest of design, so maybe outside of ArchSpec or whatever, it would be like, okay, in order to be compatible, like this value must equal that, like just like an equality thing. But for an ArchSpec case, you'd actually then have the ArchSpec itself would provide the tooling that basically, allows you to walk up this tree and then give you an answer like, yes, it's compatible, no, it's not compatible. So the way that I think about it is that, we would each compatibility family spec, whatever, would provide kind of the very basic key value pairs and the kind of the logic for determining if it's valid or not, validation rules. But then they could also they could be the purveyors of the libraries that would allow you. So for example, in a Kubernetes CSI driver, you might install ArchSpec Go. ArchSpec Go would get that, that string, walk up the tree, find that it's compatible, return true, you're off to business and running. So that's just one family, but it's a really good example because it's just very straightforward.
That makes sense to me. I mean, we could start with that. So is it okay to say that we agree with Vanessa and we should follow this path? There are any objections to that?
Yeah, I think so. Brandon, do you remember back from, of course you probably do, but do you remember back in the artifacts working group, like there was one of the initial first steps was that people went out and just like wrote up a bunch of ideas for how things would be structured, how it would work. Is that something that would make sense to do here?
Quite possibly. I think it might help break some of the logjam. People have different ideas, and seeing some of those actually written all the way out and proposed and comparing the pros and cons, that might help us settle down on what solution we're looking toward.
Yeah, I think it would help. It helps me kind of when I write something down to design it to actually think about like the steps and the problems and all of that kind of thing. And then we can maybe merge on ideas.
And while that's, I don't want to say it's a finished product just because we're still trying to get a GA out on the OCI side right now and still having drama there. The proposal we ultimately settled on wasn't even any one of the initial proposals that we came up with. We looked at all the proposals everybody came up with, and then we consolidated them all into here are the pros of this one, here are the pros of that one, and just merged them all together into one.
Being a turducken proposal. As one naturally would.
This week of all week.
Design by
Yeah.
committee.
The conversation just end. I think so. After kind of flushing out these different ideas, I think another logical thing to do, after we think about ArchSpec, is just to kind of iterate over the list of things that we might check to be compatible that we care about. So, for example, I could come up with a few things in HPC, and then I could engage with people in HPC communities and be like, hey, we made this structure. And we're kind of, it's not final, we're working on it. Are you interested in, thinking about it for this use case? And then we can get further feedback about what's missing, et cetera, et cetera.
Cool. I will do the same for telco use cases and edge devices with telco companies in Europe. So let's see if we have agreement on what has to be delivered there. I spoke with them before, but I will do it again and let's try to find some common ground. I will also ping Zvonko from NVIDIA because he's mostly concerned about confidential computing and kata containers. So yeah, we can try to figure out that.
I have been talking to my contacts at NVIDIA, trying to figure out who the right stakeholder for at least some of the things that people have discussed here are, as well for those of us who attended Packaging Con in Berlin. The thing that came up there a lot was both the difficulty of distributing CUDA libraries, which is out of the not the main topic here, but also the difficulty of reasoning around compatibility and interoperability of those CUDA libraries, especially if they're embedded in a container image. So I've been talking to somebody who's responsible for the Linux packaging of NVIDIA drivers and libraries, but basically he's expressed he's not the right stakeholder, and likewise the NVIDIA folks that we've had already express interest in this have not quite been the right for people for some of the things we're talking about either. So I don't know necessarily if there's the right person for especially like kind of the CUDA ABI and CUDA compatibility aspect, and even like as it would interface with the NVIDIA toolkit potentially, and the modification of container rootfs's at runtime for compatibility with NVIDIA hardware. But if anybody is able to reach out to their contact at NVIDIA and see if there's a relevant party, I'd encourage you all to do so.
I would ask Zvonko from India. He should find appropriate person, or maybe he will express some opinion.
I have a contact at NVIDIA that works on container things. I could ask him as well. If he can come to this meeting.
Yeah, I mean, it sounds like there's like 5 different teams in NVIDIA who have kind of touch on all aspects of this. So, I mean, maybe it could be just getting more people, or maybe it is, just enough people agitating that NVIDIA realize that there's a cross-functional concern and decides who's going to try to represent everyone. But yeah.
Okay, cool. I don't have any more topics, so not sure about the others.
So
I
should
have-
we make? Oh, go ahead.
Oh, sorry. Okay, real quick, because this is actually not a topic I have, but maybe I can incite someone to talk about. James, since you're here now, so I wanted to ask, so we've been talking about, how to express runtime features, right? So like WASI P2 components, as well as maybe even further like runtime compatibility, like use of WASIX, for example, as part of the WebAssembly work for OCI packaging and WebAssembly. Does that seem like an effort that makes sense to try to scope to part of this group, especially if we're just defining like the structure and the layout, and maybe essentially like the manifest format or the object format for compatibility information? Or do you, and we have existing fields like OS features, et cetera, that, maybe we want to start talking about concretely. Or do you think that my original suggestion of, basically defining that internally by consensus is just the WebAssembly people, essentially more in the scope of like people working on RunWASI or people working on container DShems? Does that make more sense? What I'm saying is, do you want to fold the WebAssembly stuff into this discussion, or do you think it makes more sense to kind of innovate on your own and then maybe reconcile later if necessary?
So that's why I've been joining, is to kind of stay on top of this. So I think the first way is that we could potentially fold this in there somewhere, because I think we do have some things like we want to be able to define these worlds and say, hey, you have to have this world as a runtime to be able to implement this thing, which is very WASI specific stuff. But that's like a compatibility thing to be able to use this set of components in the WASM world. So I think it makes sense if we can use the structure that you're thinking about using here to do the same thing in the WASM world. So this is the first time I've heard of ArcSpec, so I'm just reading up on it right now and trying to figure out like how that would look for something that isn't specific to like the CPU space.
Okay, so it sounds like maybe the approach Vanessa's described then makes sense, works for you, of like try to describe a data structure and conventions that can support most use cases, and then the specifics of like how you interpret that. So for like WebAssembly, how you would select, this WebAssembly image is compatible because it implements all of these interfaces, these components are available. That would be, left to in this case, the WebAssembly practitioners in that model of like, we don't define everything. We define how to structure and interpret it, and the actual specifics of compatibility and feature detection and whatnot. That is an exercise left to an interested group of end users who want to define how to do that.
Correct. Yeah, and I think we can bring that back to there's another working group in the CNCF for WASM, and that would be a good place to discuss those internal details, as long as the structure that we're defining here makes sense to be able to apply those. And so I think that's where I can help bring that up there and make sure that this structure fits the needs of the WASM space.
There's nothing else on WASM. The other one I wanted to chat about was the email thread going back and forth about libc. And I want to make sure that I guess my concern is I don't want us to go down a path. I want us to keep it into the CPU and the kernel and not get into libraries and other application level. Does that
So
make
to
sense?
that, I mean, that's where I've been this entire time very cautious and felt like, this way lies madness. I will say there was a lot of colorful commentary from the mailing list traffic too, of people who went, "Oh, what are they doing over there?" I mean, I think that Vanessa's model at least partially addresses that. Like if some people really want to like try to encode glibc symbol versioning into OCI images, they can, and not everybody has to have that inflicted on them, as it were. So maybe like, at least for me, that addresses a lot of my concerns. I mean, I have the same exact thoughts about kernel config, because it's like, this is something we do on the Moby side, is that, oh, hey, you need these kernel configs to be able to run the Docker engine. And that script actually gets referenced a bit by other container runtimes as well, because naturally they have very similar requirements. But that script has always been a heuristic and a helpful debugging tool and nothing more, because the kernel configuration system is not a stable interface. And so, there's still things that are relatively stable right now, like say, but may change in the future. An example here being actually like net filter is potentially some functionalities migrating to NF tables or maybe removed from IP tables if it was always a extension module and not part of the core infrastructure. And that is likely to mean that our script will not be entirely accurate anymore when it comes to IP tables in the next 4 or 5 years as moves deprecate and remove redundant code happen. So that to me like falls in the exact same trap as glibc of just it's deceptively implementation defined and not as stable as it maybe looks, just because it doesn't change over a period, unless it's measured in decades, right?
When I saw some of that stuff going back and forth, though, it sounded like the version of libc was mentioning that it didn't have certain kernel features that it was looking for, and so you needed to use a different version of glibc to work with whatever kernel you had there. In that scenario, if I'm understanding it right, it wouldn't care about the glibc version on the host. It would care about the kernel on the host, or maybe the CPU or something like that. Is that a correct understanding of that scenario?
As I understand it, the issue is that you're mixing and matching libraries. So there's like something coming from outside the container that has a different version of glibc that was built against, and the version of glibc that's in the container chroot or in the container rootfs doesn't have the symbols that said mixed and matched libraries expect. So it's sort of like I have stuff from the host that needs this version of glibc due to symbol versioning, and then I want to mix that into the container, for example, because to use a hardware device, I need these libraries that are going to be bind mounted into the container. They're not part of the container image itself. That was my interpretation of what was happening there, is that there's a mixing and matching of, it's the old like, if you want maximal compatibility, you need to build against an ancient version of glibc, and that didn't happen. So I need a minimum level of glibc in my container to match whatever else is coming from outside the container.
I think if you're going to get into dynamically linked libraries against binaries mounted between host and container, there's an infinite path we would end up going down.
Yeah, I thought we weren't going to scope into that, but maybe, I mean, someone could, I guess if we make it very generic, someone could. One kind of related thing that, oh, go ahead, actually, first.
No, I was just going to wrap that up with saying I'm really pushing to not go down that path. So if we can avoid that and keep it simple to where you're looking at, Vanessa, that's my goal.
Okay, gotcha. One related kind of concern that I have is that we can define the best kind of specifications for, okay, these key value pairs mean this, and this is how you check it. But then there's going to be many cases, especially in the beginning, when the annotations or whatever they are just missing. And then you're sort of at the place where we are right now. But I think what's gonna likely happen is there's gonna be a certain amount of advocacy that happens after we develop these things. So for example, if there's an artifact type for, I don't know, ArchSpec or something that's really important, we're gonna have to go, or whoever is maintaining that, and convince things that build containers to make sure that they extract those and drive them and put them and create the artifact. So I think this is ultimately going to be a multi-step process of first creating these different compatibility families, defining how to do the check, defining how to do the extraction, maybe push an artifact if that's the design that we decide on. But then there's going to be really the push for like, okay, how do we make sure this is automated and happens regularly so that we actually have the information that we need to do the compatibility check?
Actually, yeah, hopping back to the previous thing about the glibc, it sounded to me that is actually a kind of a bug. I mean, I think we could probably scrape that one off this charter, because I mean, if you start to bind mount stuff into a container, doesn't that totally like destroy the idea of a container, that it's, well, it's knows what it's doing and things like that. So I don't know. Maybe we should not enumerate glibc cases or other libraries that just hop in somehow. I think that's some kind of other level fault there at best.
I think some kind of compatibility spec could be used for that use case, because if you can understand what's in the container, then you can arguably make some kind of intelligent decision about binding something from the outside of it. But I agree that it's sort of a slightly different rabbit hole that we don't want to possibly be as our primary use case moving forward, because it is a very large rabbit hole. Never come out of that rabbit hole.
I will say, Patrick, like, it is a legitimate case. We have all of these new specs and tooling that people are building to do exactly that. And this has been something that people have been doing for a while in like less standardized forms than CDI today with things like the NVIDIA toolkit. So it's legitimate in the sense that, like, you know, by a device, and the reason that there's been all this work around like devices in the container world is more than just a Unix or a Linux device node. A lot of the time, it's often other things in the environment, whether it's a shared library or some environment variables. There's various things that need to be set up to use it properly that people don't want to encode into their own applications. But like, that being said, at least with the glibc one, like, you know, I mean, again, one with Vanessa's kind of framework for doing this, I think that is an exercise that's left to implementers. If somebody wants to reason about glibc, they're free to, and we don't have to actually take that upon ourselves. And two, like in the case of glibc, I mean, this is why we have symbol versioning. Arguably the issue, I still don't fully understand. There's not enough context for me to fully understand the issue in the mailing list, but doing my best to interpret it, the issue there is that, like, whatever it is being bound in and modified, like, simply the person who built it against too new a glibc version. So that's your problem, your fault. Of like, if glibc gives you symbol versioning for exactly this reason, so if you want to be compatible with unknown userland environments and unknown future versions of glibc, I mean, you know, it's on you to go and build that with an ancient version of glibc. Or at least this is the stance we've taken in the Python world, where we have actually codified things like glibc version into this thing we call many Linux, which is a baseline of shared object versions and userland environment that one can try to build against and then hope that any newer Linux will work. So like, we have gone down this road a little bit in Python land, and that way laid a bit of madness. So today it's mostly defined in terms of like, this is actually just Red Hat Enterprise Linux 7.8, but we just call it something different.
So as long we have a framework and we can fulfill we can fill data with our own use cases, I think from telco perspective and edge devices will be happy. For us, it's okay if, you know, over time kernel configuration or whatsoever or whatever any configuration is outdated. It's totally fine. It's just image auto responsibility to keep everything up to date, the compatibility specification and so on for the image. That's totally fine from our own perspective. That's why I came up initially with this idea of artifact, because I didn't want to put this kind of data into image itself, because that could explode easily. So yeah, I think Vanessa's idea makes a lot of sense.
So for next week, I guess, do different folks want to start working on just brainstorming drafts for ideas? I think, for example, Christian and I can probably come together and start to hack together some ideas for what we have in mind that would kind of work toward the use cases that we know. The thing is that everyone in this call and people probably not in this call that could participate, we come at this with different perspectives. So like the designs that we come up with are going to reflect those perspectives, which is why I think it's important that we kind of, we don't all work on like one design and then we can come together and talk about them.
Sounds good to me.
Did we call it a bit early this week? Does anyone have any other niche topics they want to bring up or anything?
I'll just say keep in mind short week with Thanksgiving, so people may not be on top of it first thing Monday morning.
Oh yeah, that's a good point. Yeah, so the goal is to start if you can. If you can't because you're hanging out with turkeys or turduckens, that's okay too. But I'll probably start at least thinking about it. Once something starts rolling in my head, it's hard to stop it from rolling, even when there are turkeys around.
So, Vanessa, could you answer to the mailing list about the recent ideas you had and how we should proceed?
Yes, absolutely. And I'll kind of, I suspect there are more people on the mailing list than show up to this meeting. So probably others in the list might want to kind of think about it, contribute to that. So yeah, I will.
Okay, thank you. And I think James wants to say something.
Yeah, I was just wondering, is there a good example of this type of design that you're like the arc spec? Like I was just reading through the docs and they're showing a bunch of Python and stuff, but I don't see like an example of the JSON that they're resembling.
Oh,
so just so I have a sense of what we're kind of talking about.
Yeah, so for the Arch spec example, if you look in the Python repository, there should be a directory CPU somewhere, and there will be actually a link to another repository that just has JSON objects for I think it's called microarchitectures.json, and then there's another one that has a spec for that particular thing. And then for actually where that's used, you could look at, for example, the spec package manager. That's where that uses an ASP solver that's going to bring in that metadata and figure out if it's compatible. If you want examples of kind of the design documents that I kind of anticipate we're working on, Brandon, correct me if this is like a bad suggestion, but I think we could at least look at the artifact working group, different design docs. There was just like a bunch of different markdown files for that.
Great, thanks.
Okay, cool. I answered your question.
You gave me enough to go do some reading and learning, so.
Okay. Yeah, I guess I think ArchSpec is a good starting example because it's very simple and kind of the logic for determining compatibility is already there. But that is by no means the only thing that you could start thinking about. You could also just start thinking about this very generically, I think.
Okay, guys, then I wish you a good day and see you the next week.
Yeah, thanks everyone. It was fun. I will follow up with an email, and if I don't chat with folks here, for those that celebrate Thanksgiving, have a great Thanksgiving. If you don't have celebrate Thanksgiving, have just like a great end of your week or / entire week and then the end of the week. Yeah. Okay. Bye everyone.
Bye bye.
Bye bye.